Hello students, we are going to look at a few more examples of alkene oxidation, 2A, 2B, and 2C. Again, please pause the video while you're working on these and check back, because when you practice on your own instead of just watching me practice, that's how you learn it, right? And most importantly, I know you all think mistakes are embarrassing and you hate to make mistakes. Mistakes are how you learn. And if you don't actually go through and actually try this out and make some mistakes, you're not going to have as much learning. So please try these out. Now we've practiced with a few of these already. Let's look at this one. Here's an unusual compound. This is cyclobutene with potassium permanganate and cold base. Right? I want you to write the product that you're expecting for that one. Cyclobutene with potassium permanganate, hot acid. Go ahead and write the product that you expect for that one. And here's another one that's slightly unusual. This is 1, 2, 3, 4, 5. So this is pentene, and not only is it pentene, it's actually penteneol, right? So this is something like 3-pentene-2-ol or something like that. Let's pretend like we're gonna react that with potassium permanganate and hot acid. Take a minute right now, pause the video, try these out, and then we'll come back and look at the answers. All right, now that you've gotten a chance to try these out, I want to go over a couple of more fine details that were in the handout, but I want to make sure that you got these little bits of details. First of all, we know that if we have potassium permanganate and cold base, we're going to oxidize this alkene, but we're not going to rip that bond clean apart. We're just going to make alcohols. And the alcohols are going to be neighboring alcohols. They're going to be on this carbon and that carbon, the vicinal alcohols, the vicinal diol. And something that's important to pick up is that if this is a ring, and only if it's a ring, because of the mechanism of how this happens, right, this molecule will sit on top of that molecule, and so both of the alcohols will be on the same side of the ring. I chose to make these both wedges. If you wanted to, you could make them both dashes. It doesn't matter, but it's important to show the stereochemistry here. Okay, if this is a ring and you're doing alkene oxidation and cold base, you must show these alcohol groups on the same side of the ring. So please make sure you show that for rings. Let's look at this one. Right here we have that same cyclobutene with potassium permanganate hot acid. I think about this as like a chainsaw, and it just goes, it just like cuts right through here, and we're going to oxidize both of these carbons as far as they can go. If we have a ring and we cut it clean open, we're going to get a linear compound. So count your carbons, 1, 2, 3, we got 4 carbons. Here's my 4 carbons, and this one and this one are now the ones on the end when you open it up, this one and this one. If you have primary carbons, what is the most oxidized they can be? Acids. So make each of those acid groups, right? So now we have something like, what is that? Butane dioic acid, something like that. Right, so that looks good. Let's look at this one. Right, once again, we have powerful oxidizing agent, potassium permanganate and hot acid. We're gonna do a buzzsaw, cut that clean open. So now we have a 2-carbon compound. Oopsies, messed that up. See, you learn by making mistakes. So that piece is this piece. And then how many pieces we got left? We got 1, 2, 3. So 1, 2, 3. And this piece is this piece right here. We're going to oxidize that as far as it can go. And we need to make one more alteration, one more modification to this molecule. What happens if you have an alcohol, in this case a secondary alcohol, and you put it in the presence of a powerful oxidizing agent? Right? What happens is this thing gets oxidized. Right? So if you have a secondary alcohol and it gets powerfully oxidized, what happens to it? It actually gets converted into a ketone. So please pay attention to that. If you have any alcohols anywhere in your molecule and you expose them to potassium permanganate in hot acid only, they're going to be oxidized as far as they can go. So either to the ketone, or if they're on the end, if they started out as being a primary alcohol, they're going to be oxidized all the way to another carboxylic acid. So please pay attention to that. Now, if you have not already, I want you to try out these practice with alkene oxidation exercises. And there's also will be solutions posted, so please, after you've done these, check your answers.